Welcome back to the Rice Robotics Club Robo-Tutorial. In this video, we'll be doing the CAD for this pulley and then the belt that connects these two pulleys together, which doesn't show up in the CAD because it's inconvenient to put it in the assembly. But we'll be making this pulley and the associated belt. So I'll show you what those look like individually. Here's the pulley we'll be creating. And then we also have the timing belt here. So we're not going to CAD these from scratch ourselves. You could, but the geometry around that makes up the teeth of both the pulley and the belt are kind of specific, and it would be difficult to replicate that totally accurately. So instead, we're just going to take CAD models from McMaster-Carr from online and just scale them and correct them so they work for our use. Okay, so we're back in our the Onshape file that's in progress, but we're not going to create a new part studio. Instead, we're going to go to McMaster. Just going to Google McMaster pulley. Go to pulleys. We're looking for timing belt drive pulleys. Scroll down, looking for these high strength HTD pulleys. Okay, so there's a bunch of options here. For our purposes, we're going to use a 5mm pitch pulley, which means there's 5mm distance between each of the teeth that go around the pulley. And then just because it's the one that I used whenever I designed this initially, we're going to use this one that has this product number. So select that one. It's 6497K272. In reality, you probably don't have to use that specific one, but that's just the one that I've already used and created instructions for. So we're going to roll with that. Down here it says you can download the 3D SolidWorks file. So we're going to download that. And then we're also going to go ahead and find our timing belt. So it's already there. Look up Master Timing Belts. The timing belt section, we're going to click on timing belts. Scroll down. I believe we're looking for high strength HTD timing belts. And so it's important that our belt and our pulley pitch is the same, this distance between teeth. That's how we know that they'll be compatible with one another. If they have different pitches, it's not going to work. So we need a 5mm pitch timing belt. And then we'll just take this first option here. So click on the product number. It should say 7939K527. Download the 3D SolidWorks file. And now we have the two files that we're going to import into our Onshape file. So we go down to the file select, click import. We'll first import pulley. Just accept the defaults here. Go ahead and start the import for the timing belt as well. Accept all the defaults. Okay, so as those are loading, see here, we have the timing belt, and then here we have the pulley. So that's great. This gives us a nice point to start from, but we do need to make some small changes so that these are like more compatible with our design. For example, we don't need this big cylindrical attachment at the top here. We're going to remove that. We're going to fill in the hole that goes through this, and then correct a few other things before the pulley is ready to go. So we're going to start by removing the cylindrical part on the top. We're going to do that by creating a sketch on this top face. Right click, view normal to sketch plane. Okay, so we're going to draw a circle centered at the origin. Select circle from the sketch toolbar. Click the origin to center your circle there. Just drag out. This is going to have a 7.3 section. It's going to have a 42mm diameter. So click dimension in the sketch toolbar, click the circumference, and give it a 42mm diameter. You can see that kind of just goes right around the edge of the pulley there. And then we're going to extrude down. We're going to remove material all the way up to this flat face of the pulley right before it transitions into the section with all of the teeth. So we'll go ahead and extrude this sketch. We're going to be removing material. And instead of a blind end type, we're going to use an up to face end type. So select up to face. And we're going to select this top flat face here. It should remove everything above that point. So you can see it leaves these two bodies here. That's because this pulley isn't one body. There's actually 3 separate bodies. And right now we only have the merge scope set to merge with part 1, which is like most of the pulley. So if we're going to remove these as well, instead of having the merge scope be part 1, we need to select merge with all. And then it actually removes all of the material that we don't want. So this feature is good. We're going to click the green check mark. Great. Okay. Our next feature will fill in this hole through the middle of the pulley because we don't really need that for our design. So we're going to create a sketch on this top plane. Right click, view normal to sketch plane. Okay. Then we're going to draw a circle centered at the origin. And in this case, we just need it to be the same size as this middle hole. So there's several ways you can go about doing that. I'm just going to use an equal relation from the relation menu and select both of these circles and make them equal. So this is fully defined. Now we're going to extrude this sketch. And so far, we've always used blind or other end types. We haven't used a through all end type whenever we're adding material. We've only done that when we're making holes. But you can totally use through all for adding material as well. So that's what we'll do here. Select through all, and then this is extruding in the wrong direction. We need to flip it so that it extrudes down. Let's see, I was wrong. It is a problem. Unless, oh, so we need to make sure we're adding material. In this case, you can see this is blue. That means that it's creating a new body, which is a problem. That's why our through all end type didn't work. So select add in the extrude dialog. We're going to select merge with all. Okay, no, I'm just done. That's not how it works. Okay, so let's X out of the extrude dialog. Okay, we're just going to use a blind or an up to face end type instead. Sometimes I forget how things work. So select that sketch we just created. We're doing up to face extrusion. We can flip this around again so it's going through the pulley. And then we're just going to select the face on the other side so that it fills in all of that material. Go up to this point. That should be good. Okay, so you see that there's a little bit, there's our edge here. We have extruded all the way up so it's parallel with this face, but there's a bit of like a chamfer there that's transferring from this flat face to the extrude that we just added. So we actually need to make that circle in this sketch a little bit bigger so that it fills in all of this area, because that's just going to be kind of a weird feature to 3D print. So we want to avoid that if we can. So this is wrong actually, so we're going to remove the equal constraint or the equal relation because we actually want to make this circle bigger. So we need to select the circle. I'll show you that again. You need to select the circle or hover over it, and you'll see the constraints appear that are acting on that circle. Click the equal sign and delete it. And now you can see that this is once again underdefined because we've removed that relation. So now we're going to add a dimension to this circle and make it 8 millimeters. And now if we click the green check mark, the extrude will automatically update. And if we look at the other side, it should now be nicely filled in. There's no more extraneous geometry on this side, which is good. So that's great. Make sure to always name your features as you're creating them. This one. Top. Center. Okay, cool. So we need to do one more thing to fully correct this pulley geometry. We're just going to flatten out this side so that we don't have this more like complicated geometry going on. It's just going to be a flat surface, which will make it a little bit more convenient for 3D printing and stuff like that. So we're going to create a sketch on the lowest face here, and then we're just going to extrude up away from that surface so that we flatten it out. So create a sketch on this lowest face. Okay, right click, view normal to sketch plane. Now we're going to zoom to fit, and then we're going to use the use tool. The use tool will project any geometry that we select onto the sketch plane. So in this case, if we use I can't say it like that. That's very confusing. If we select the use tool and then we click this circle, it's going to just add that circle to our sketch plane, and then we can use it in our sketch. So click the Use option, click this outer circle, and now we have a fully defined sketch. It's just that circle in our sketch plane. Great. Okay, so now click the green check mark, and now we're going to extrude this sketch that we've just added. And we're just going to be adding material. Not near that thick, that's crazy. It's going to be 1.8 millimeter depth. And that'll just create a nice flat surface on this side. That makes 3D printing more convenient. Okay. So the next thing we're going to do is we need to scale this pulley. This is a little bit too big to incorporate in our design. Or actually, the reason we're doing it is because the belt, whenever we go to the belt, it's going to be too long. So we're going to want to scale down the pulley. So to get ahead of that, we're going to go ahead and scale it down now. And then we'll add an attachment for the servo. So the way you scale a body in Onshape is you use the transform command. So select transform from the feature toolbar. And you can transform it in a bunch of different ways. Select the pulley, because that's what we want to transform. Now click the drop down. We want to do a transform type of scale. And then we're going to scale about some point. In this case, it's just going to be the origin. That's convenient. By some factor. So our factor here is going to be 0.853. Very specific, but that's just based on some calculations I did. This scale factor is what will make our belt the correct length for the end design. And so that's what we need to use. The reason we need to scale the belt and the pulley by the same amount is that so that they'll still be compatible. Remember that the pulley and the belt have to have the same pitch. So whenever we multiply, if we scale the whole pulley by this factor, we're also reducing the pulley's pitch by the same amount. So we need to make sure those pitches stay the same. So we have to scale both the pulley and the timing belt by the same factor. So that's what's happening. The green check mark. Okay, make sure to name your features. Okay, so it's almost fully corrected. Now we just need to add some method of attaching the servo horn to this pulley. So we need to add basically the servo horn profile to one of these flat faces of the pulley. And we can't use the servo horn that we have in CAD. If you remember in the assembly, we have a servo horn in here, but this doesn't match the servo horn that we'll be using once we actually build the robot perfectly. So we need to take some measurements, which I've already done. So you don't have to take the measurements in this case. But if you're in this situation, you'd want to get some calipers, measure the servo horn, and figure out how big this gap has to be so that the servo horn will fit inside. So this will make a little bit more sense as we go through the process. But for now, we'll go ahead and create a sketch on the bottom flat face of this pulley, right here. Okay. And now we're going to start by creating a rough, approximation of what the servo horn looks like. So we're going to start by doing a circle. Click the circle tool. It's going to be centered at the origin. So create a circle, and then we're going to add a dimension that makes this circle 7.3 millimeters in diameter. Now we're going to add another circle. It's not going to be centered at the origin, but is going to be horizontally aligned with the origin. So make sure that that relation is getting added by the dotted line. Click. And then this circle is going to have a diameter of 4.2 millimeters. And you'll see that this circle still isn't fully defined, and that's because this circle is centered at the origin. So we already knew its position. But this circle, it's horizontally aligned with the origin, but can still slide in this direction. So we're going to have to add some dimension here to specify the position of this second circle. And so we'll go ahead and do that now. The horizontal distance between the center of this circle and the center of this circle is going to be 16 millimeters. And that fully defines those two circles. You'll see that this circle is just slightly off of the pulley. That's actually okay, and you'll see why soon. So we needed this circle to also be on this side. So we're going to use the mirror tool, like we've already done several times. select the mirror tool from the sketch toolbar. You're going to choose this line that's dividing the pulley vertically. And then you're going to mirror this circle onto the other side. Great. Okay. Now we need to add some lines to fill out this profile. We're going to select the line tool from the toolbar. We're going to start the line at the top point of this circle, the point that's vertically aligned with its center. Okay. And then we're going to make it coincident to the circumference of this circle, the larger circle. Okay, and then we are going to right-click, escape the line tool. Okay, I've messed up. This is not supposed to be horizontal, and this is what happens sometimes whenever you're adding a sketch entity in Onshape, it'll just automatically add a constraint that you don't want, and then it can get confusing. So we're just gonna go ahead and delete that line. Try it one more time. Line's gonna start at the top point of this circle. It's not. Okay. Also, what I did just there, sometimes if you're just dragging along the parameter of the circle, it might not automatically add that vertical relation. But if you start at the center and then you go up, it'll often add it, which is weird that you have to do that, but it happens. So, okay. Make a Wednesday here. Escape line, and then we're going to add a tangent relation between this line and this circle. And that will fully define that line. Okay. So we're going to do a few more mirrors here. First, we're going to mirror this line about the line that divides the pulley horizontally. Okay. And then we're going to deselect the mirror and then reselect it to start a new mirror operation. Select the line that divides the pulley vertically. And then we're just going to mirror both of these over as well. And now this, based on the measurements that I took with some calipers, is a rough approximation of the servo horn geometry. And so now we're going to create a cutout around it so that the servo horn fits into our pulley nicely. So first thing is we're going to convert all of this to construction geometry, because this isn't deciding the cutout that we make. It's just there so that we can reference it. So we know basically how much space the pulley or the servo horn will take up. So just select all of those entities and we're going to convert them to construction using the construction tool up here. And now they're just there for reference. They're not actually defining what our cutout is going to look like. We also need to divide this circle into 4 arcs using the split tool, like we've done several times already. So we're going to choose the split tool from the toolbar, and we're going to select all of the points where a straight line intersects this circle. Okay. Make sure both lines are highlighted and click. Click again to complete the split. I have this arc. Oh, it messed up. Let's see. Okay, now we have a small arc and the rest of the circle. We're going to do the same at the bottom. Start the split here. Hit here. And now we have 4 distinct arcs. And that'll make our next step a bit easier. So now we're going to perform 2 offsets. And so we're actually we're gonna have to split it into 2 different offsets because you can only offset one chain at a time. So if you're gonna offset a set of lines, they all have to be like continuous with each other. So I'll show you what I mean by that. So we're going to select offset from the sketch toolbar. We're gonna offset this line, offset the small arc that connects these 2 straight lines, and choose this one as well. We're gonna flip it because we're gonna offset outward so that the pulley horn has some space, or the servo horn has some space. Okay, so we're going to flip that offset to the other side, and then we're going to specify an offset distance of 1 millimeter. Now we're going to have to do the same thing on the bottom, but why can't we do it at the same time, right? So let's try and select this line and see what happens. It says you can only offset a single chain at once. So this line is not in any way connected to the rest of this chain. So you're not able to offset it at the same time as we're offsetting this top chain. And we don't actually want to offset this arc, which would connect it, for reasons you'll see in just a second. So deselect that. Now this offset is good. Confirm that 1 millimeter offset distance. And these endpoints are still undefined because you can drag this line like this. So just drag it to the circumference of the circle and do this on both sides, and then it's fully defined. And now we could either mirror these lines to the bottom, or we could just offset again. We're just going to offset again in this case. Select offset from the sketch toolbar. Do the same as we did above. Select the 2 lines and the arc. Make sure that distance is 1 millimeter. Wow. 1 millimeter. Confirm the distance, and drag the endpoints to the circumference to fully define. Cool. Okay, now this is almost the profile that we're actually going to cut out, but still not continuous, right? We need this bit of the circle to complete the profile so that we have a closed shape that then we can extrude and remove material from the pulley. So to do that, we are going to select the Use tool, okay? And we're going to project this outer edge onto our sketch plane because we want to use this circle to complete this profile. So select the Use tool and then select this circle and it's added to our sketch. Last step is we need to use the Split tool to split this circle into 4 different arcs. So click the Split tool, do exactly as we've done several times already. Split the circle up into 4 arcs. Okay, and now we have the 4 distinct arcs. And then we just need to convert the 2 big arcs, which we don't need. We only want these small arcs to complete this profile. Select the 2 larger arcs and convert them to construction. Great. Okay. Now this sketch is fully defined. Our profile is done. That was a bit of a complicated one, but we're good to go. Click the green check mark. Now we want to extrude this into the pulley. We're going to be removing material. Select that sketch. We didn't do anything wrong. It looks like we did something wrong. Let's see. Reduce this distance. Yes, okay, we've messed something up. Let's go see what it is. Oh, okay, it didn't convert to construction for some reason. I'm not sure how I messed up. I'll have to see in the playback. But okay, it's converted to construction, and now everything should be ready. There we go. So that is too deep. We don't want to remove that much material. So you go back and edit this extrude, removing material using that sketch that we just finished. And we're going to extrude it, removing material with a depth of 1.5 millimeters. Great. Click the green check mark. So I made a mistake here. So this is a good chance to show something up. So I extruded this on the wrong face. I did it on we have 2 different faces of the pulley here. One of them is skinnier than the other. So now I'm like interfering with the teeth. But if I do this extrude on this side, then it won't have any issue. It'll have plenty of material to work with. So to fix this, it's not actually that difficult. We're going to have to go back to this sketch that we just made with the servo horn profile. We're going to edit. I'm going to change this sketch plane, okay? So remove this sketch plane. And we actually want to have this feature be on this face. Select this face. And now it's automatically, the sketch entities are all in the right spot still, just on this other face. And now we may have to fix our extrusion as well. Oh, we don't. It's great. Okay. Cool. So yeah, if you make a mistake like that, it's pretty easy to fix. Just edit your sketch and then change the sketch plane. And then you're good to go. Okay. One last very simple feature we need to add. We need to add some mounting holes so that we can bolt the servo horn to this pulley. So to do this, we're going to create a sketch on this face that we just created with the servo horn cutout. Do normal. Okay. So we're going to draw 2 center point circles, not centered at the origin, but they are going to be horizontally aligned with the origin. Okay. So they're both properly aligned. They're going to have the same diameter. It's going to be 1.915 millimeters. So that is a very specific number. And the reason is you have to be very specific with these hole sizes because they're meant to fit a very specific type of bolt. So I'll talk more about hole sizes once we get to the sort of tolerancing section. But for now, just make sure these holes have the same very specific diameter. So I would use a dimension to define one of their diameters and then apply an equal relation to make sure they have the same diameter. Okay, but they're still not fully defined because neither circle has its horizontal position specified. So we need to add some dimensions to do that. So this circle that's further out, we're going to add a dimension between its center and the origin. And the distance is going to be 11.05 millimeters. That's another measurement that I took with calipers when I was working with the servo horn. And there's going to be a dimension from this circle center to the origin, and it is going to have a distance of 6.05 millimeters. Okay, so we have two holes on this side. We just need to mirror them over here. Select the mirror tool, select the line that divides the pulley vertically, and then select both of these circles to push them to the other side as well. And now this sketch is complete. So now all we need to do is extrude this sketch. We're going to be removing material, making some holes in this pulley, and then we're just going to use that through all end type. Click the green check mark, name the feature, and we're good to go. So the pulley is finally complete. So it's good news, but now we have to do the timing belt. Okay. Also make sure to rename these. They have pretty crazy names when you import them. But just rename them to something you'll recognize. And now we have to do the timing belt. Fortunately, the timing belt is much, much easier. There's really only two things we have to do here. First, we're going to scale it just as we scaled the pulley. So we know how to do that already. Select transform from the toolbar. Make sure that your transform type is set to scale. We're going to scale this pulley. And then we're going to scale it also about the origin, just as we did with the pulley. And we're going to do the exact same factor as we did for the pulley, which was 0.853. I'll make the belt a little bit smaller, but make sure it's compatible with that pulley. Okay. Only other thing here is we're going to remove some material. We're going to make this a bit thinner. That'll just make it more flexible and a little bit easier to implement with our design. It's pretty easy to do. All we have to do is create a sketch on the top face of this belt. Okay. We're going to right click normal the sketch plane. So we're just going to make a rectangle that's big enough to remove all of the material of this pulley of the belt at once. So choose center point rectangle. Click the origin so that rectangle is centered there. And then we just need to make sure that this rectangle totally covers the belt area. The way to do that is first to add we're going to make sure these two lines are collinear, or in this case, we're just going to use coincident. It's going to make them coincide with each other, I guess. And then we're going to make this line and this curve tangent to one another. And then it's going to be the perfect size to remove material from this pulley. I guess you could have also just used the use tool to remove material, but this works too, so it's no problem. It's not complicated. Okay, now we're just going to extrude this down and remove some of the belt material. But not all of it. We're going to remove 3 millimeters from the belt height. That's just going to make it a little bit easier to work with once we 3D print it. Very cool. And now the belt is already complete. Okay, make sure to rename that file to something you'll recognize, like just timing belt or something like that. Great, and now these two parts are complete, and they're ready to be printed once we get to the build phase of this process, and we're ready to move on to the next video.